let's welcome Ram from Cloud Foundry. And Ram is an engineer by practice, educator at heart, and so he became evangelist and never looked back from that, and enjoys helping engineering teams around the world discover new and creative ways to work. And yeah, his talk is Build Pack Go, proving the Go Kubernetes deployment experience. And yeah, let's welcome him. So happy to have you.
Thanks, Ola. Thanks, Natalie and Tim as well. Is that nothing breaks. So let's get right into it. So for the next about 20 odd minutes or so, I'm going to walk folks through what build packs are, how they came to be, and what new sort of avatars they're being produced in right now. But even before we do something, um, let me kick this off with more of a show, and then we can switch to the tell. So what I'm going to do is look for like a random Go code base, and what the build packs basically want to demonstrate to folks and want to prove is the fact that you don't need a Docker file in order to build like containers and work with them. So what I'm going to do right now is I'm just cloning like a code base. I'm going to first delete the Docker file, not even going to see what's in it. Yeah, it's gone. So I'm just going to do a pack build. And I know what I'm typing right now might not mean much to a lot of folks, but hopefully in the next 15-20 minutes, we have enough to um, gives us enough of a base to talk about. Okay, so while this fires off on the side, we're going to switch to a bunch of slides. So folks who are really curious can continue to look at what's going on the side. So the title of today's talk is Build Pack Go. And no prizes for guessing, but it's basically about build packs that make use of Go. For those who have not heard of build packs before, build packs are a way for developers to take their application code and transform them into immutable artifacts that they can just deploy. A long time ago, it was binaries. So if you were working with Java, it was Java binaries. If you were working with um, other languages, it was just different binaries that were built in these languages, and these binaries could then be deployed onto your infrastructure. Now we've come a long way from having binaries as the immutable artifact that gets deployed. We've moved to containers, and so along the way, build packs also evolved into becoming a tool that basically took your source code and started to generate a container instead of a binary that you could deploy. Now, as is um, you know funny, let's say, with the world of technology, different companies started to perceive this process in different ways. And then although build packs were pioneered at Heroku, there was a fork along the road, and Pivotal, now known as Cloud Foundry, and by various different names commercially, uh, had its own version of how they created build packs. And Heroku continued down their own path of how they wanted to create build packs. Now, nearly 10 years after the start and all of this divergence in the middle, the teams at both Heroku and Pivotal have come together, and they have started what are known as the cloud native build packs spec. So the cloud native build pack spec is owned by the CNCF, and their website is buildpacks.io. So what do these actually do? So basically, the promise is the same. So you have your source code, you want to transform it into a piece of into an immutable artifact that you can deploy to your infrastructure, and that promise continues to hold good. So cloud native build packs is a specification, and then there's what is known as Paketo, which is an implementation of these build packs. Now we'll get into uh, the details in a bit, but one of the first things that you'll notice is they want folks to avoid managing Docker files. So Docker files is not the enemy. I don't hate it. We all write it. We all love it. We all are very familiar with it. But writing and maintaining Docker files just represents a significant amount of toil and requires a lot of mind share, and basically deviates developers from basically doing their thing. So the architects of the cloud native build packs decided to take an approach where they basically said, let's find a way to do away with complex Docker files, and let's continue to see if um, build packs can function and can continue to help out. So the output of the build pack, and I'm going to just skip a few slides here and there, please don't mind me. The output of the build pack process is an OCI compliant image. So as you can see here, what I did at the start was, after I had cloned this bit of code, I just tried to build it. So this command actually creates the container for me, and we'll dissect some parts of this in just a bit. But basically, this build pack goes in, detects whatever language or framework the code is in, finds the appropriate build pack, um, and you can see here, finds the appropriate build packs, and then does the actual build process itself. Now, it's doing this without the need for like a YAML file or a Docker file or any of these additional things. So it can basically figure out just based on whatever code is there, and it can create that container for use. Now, let me quickly look at the doc and see what this does. So not much information, but I'm just going to use the Docker runtime to see if this will run. Yeah, so looks like it works, although it doesn't do something very useful, but at least the process didn't fail on us. So what exactly is going on here, and what is it that is actually enabling all of this, is what the focus of this talk is going to be. So like I said, there's there's the cloud native build pack specification, right? And then the cloud native build pack specification created this tool called the pack CLI. Documentation for the pack CLI is available here. So the pack CLI is basically what the cloud native build packs team recommends as the interface for creating these containers. Pack will so basically pack is run against your source, and just like you would do a docker build xyz, pack is capable of figuring out what the language is. This will work uh, exactly the same way if I was talking at a JavaScript meetup as well. So I'd find like a Node.js code base, remove the Docker file, run pack build, and it would give me like a container that can run. So pack is capable of figuring out, or rather the build pack is capable of figuring out what the language is. In the first stage here that you can see in the logs, which is the detect phase, it basically figures out all of the different dependencies that are required. So it reads the uh, go.mod and the other um, files, and then it creates an environment where uh, all of the vendorized sort of version of all the libraries are available, and the go build is available as well. And then it moves to sort of the build phase where um, you can see here that different layers get built. So if you were to run this again, let's say, what will happen is a lot of caching also happens where the um, different layers are basically reused and recycled. So that is another thing that happens, which I will also demonstrate in a bit. But basically, the build checks for different things that you need and actually builds the target. And finally, all of the different layers for the Go app are actually exported. So once it's exported, parts of it is also cached, like I mentioned. So if I was to run back build once again, it'll find that an image with the same name and other things is already available, and it'll just serve that locally instead of going through all of the process. So um, yeah, for those who are actually paying attention, so if you look at this, it's just restoring all of this information from the cache, and the build actually executes. Um, so in a reasonably faster amount of time, um, which you can compare here. So what is um, inside this? So we can inspect the builder. So this is the builder that I used. And if we inspect the builder, we'll find like what the build pack actually does internally. So um, yeah, so this is where it begins. So the builder, or internally the build pack basically has um, a list of, let me make this slightly bigger. Yeah. It has like a list of other smaller build packs that it can connect with. So there is an order in which it detects, and so it looks for certain files and artifacts that it can say with confidence that this is sort of the um, language or framework that is being used. So if you notice here, um, there's a handful of different Go build packs that it can pick from. So the highlighted section is the part of the build pack that once it detects that there is a Golang app that is being built, um, it'll process each of these different groups of build packs. Now, for again, our build process made use of this first group that basically has GoDist, which provides like the basic runtime for the app, mod vendor for managing all of the modules, and build to sort of tie this together. Let me quickly show you. Um, yeah. So on GitHub, um, so again, all of this is open source, made available for folks to examine and take a look at. And basically, there's implementations for these different processes that the Go build process might encounter. So there's um, the distribution, the Go dist. Basically, this is Go mod vendor, and this is Go build. So of the different build packs, these three were used. So those are the three that are in this first group. So that's basically what is inside um, the the build pack. We can also sort of examine the container itself that comes out of it. um, I've used dive in the past. Yeah, so this is these are the internals of the container itself. So uh, for folks who are interested in taking like a deep dive into what the image actually contains, this is like super useful. So I'm going to skip the details on that for want of time. Um, and then we can take a look at another example also, maybe. So I'm going to try and do the same thing for like another project. um, so let's see. Same rules. Remove the Docker file. And I'll demonstrate one or two other things. So um, you can use like a bunch of different builders depending on what your use case is. So like I mentioned, cloud native build packs uh, have implementations in different forms. So GCR has an implementation, Heroku has an implementation, and Paketo is like the open source implementation that I just showed you. So think of each of these as like a base image equivalent when you come from like the Docker world. And like last time, we made use of builder base. So I'll just show you that thing. So yeah, we made use of builder base. This time, let's make use of a smaller builder and just see what the output is. Um, the process is very similar to creating like a Docker file. So because I did not use um, builder tiny before, it's going to like download the whole internet and then get into the same phases that we saw earlier, right? So but yeah, basically, a bunch of different layers that it requires get downloaded, and the actual detect, analyze, and all of those phases will kick in. So while we wait for that to complete, let's see. Yeah, like I mentioned, um, Paketo is an implementation of the cloud native build packs itself. So Paketo has support for like different languages. Um, One of the things that I think would be very happy for this group is all along its lifetime, Pivotal and like a lot of efforts at Heroku and all of these places. Um, Java had been like the first class citizen. A lot of this stuff was written in Java, later rewritten in Ruby and things like that. But Go is like a first class citizen in the build packs world right now. A lot of the build packs itself are written in Go. So it's I just thought I'd mention that. Um, and yeah, so the container has been built. um, the process, like I showed you last time, was very similar. So compared to last time, there's only two build packs that are participating this time. A previous image was not found, so nothing restored from cache, but like a bunch of different build processes ran. And again, there's nothing extra that we had to mention in terms of what the language is, where to find the files, or any of these things. And it just was able to find everything on its own. So hopefully like a Docker run um, will work here. Yeah, so I'm going to quickly run this. Mm, and then specify the thing. Okay, so let's see. Not sure why.
The documentation named another part, right?
Yeah,
But
I did. So let me not switch that then. Oh, well, it's not a good demo if something doesn't break. So okay, and then you can hit, yeah. So there you go. So once again, just like um, so you base, that's what it returns. So basically, um, you know, you you can pick any code base, you can start tinkering with it, and get stuff working. So um, yeah, in terms of slides, I think we've covered like um, a bunch of different things in a slightly different order, but I think important features is builds can be easily reproduced. Um, there's something called rebasing, and there's also a bill of materials sort of thing that's been introduced that folks have found very useful. Um, Paketo, which is again an implementation, um, is built with the goal of making it uh, obviously making it technically proficient and things like that, but also for like folks to be able to easily contribute, because like back in the day Cloud Foundry build packs were also open source, but it was not the easiest to contribute to. So a lot of things have changed in terms of governance with Paketo, and folks can just um, feel right at home when you want to try and jump in and start contributing. So again, I wanted to highlight the fact that like a big part of the build packs themselves are written in Go. So it doesn't matter whether it's like a Node.js build pack or any of these other build packs. So like um, they're all written using Go. Uh, then what else? Yeah, I mean, you saw how like different build packs participate and contribute to like different layers. I had like a bunch of FAQ that I've received in the past. Let me just quickly run through them. Are folks even using build packs in the world? Yes. So uh, Cloud Foundry is implemented at like tons and tons of different projects. All of those are built using all of those apps are basically built and deployed with build packs. Any apps that made use of Heroku um, are all using build packs underneath the hood. Yes, these can be used for local development. So it's just like an OCI container. So whatever is your container workflow, you can basically fit it into that. You can also use it in like a CI CD workflow. So one of the other things that Pack can do is I'm just going to go ahead and build like a third one here, and then all you have to do is say publish, provide your registry credentials, and it will get published to like your um, container registry, whichever you have. Um, so just add the publish tag and give your container registry credentials, and then it gets deployed there. Thereafter, you can just pick it up and have it deploy to wherever it is that you want to. So yeah, just another another useful thing. Yeah, so we just covered that. Yes, it is open source. I'll leave links to this. And yeah, I mean, the important takeaways, do experiment with it. Again, I am not the most proficient Go programmer in the world. I probably shouldn't even be in this meetup based based just on my Go skills. But what I've found is a lot of folks who are experienced Go developers have had a lot of success making use of build packs to build these containers and make use of them in their workflow. So I would definitely love to invite all the folks that are listening uh, to try. Using Pack to make your containers. Not that I have anything against Docker or using Docker files, but it's just a newer and interesting way to be building containers and making use of these. So that's one thing. The other thing that I wanted to highlight, I've said this a couple of times, a big chunk of the build packs themselves are written in Go. So if folks want to hop in, take a look at what how these things are being authored, and want like to pick on a few issues and start contributing to this open source code base, you're more than welcome to do so. So uh, we have a good contributor experience. We've had it in the past, and I'm sure that folks will continue to contribute and appreciate what we have. So um, if you want to reach me for anything, that's my email. I am a Twitter bird to the point of being an addict, much to my wife's annoyance, but Twitter is a good way to reach out as well. There is, I forgot to put this on the slide, but there's like a Slack channel for Cloud Foundry where you can talk about build packs. There's also one for Paketo itself. So you can find these on paketo.io, which is like um, a good resource if you want to get started. So you can hop into the Slack channel from there as well. Quite active. We're more than happy to support any experiments that you folks might be running and help you with it. So yeah, I've spoken a bunch. Going to shut up now and see if anyone has any questions or if I can help folks with anything at all.
Thanks so far. Thanks a lot.